This video, we're going to talk about transformations specifically of parabolas using something called the vertex form of the parabola. And we're going to get to the vertex form of the parabola by something called completing the square. Our objective is going to go like this. We're going to start off with something in standard form that looks like this, and we're going to try and transform that by a process called completing the square. Into the general form, the vertex form that looks like this. Talked about that a little bit in our transformations video, and how this is a very specific case of the general form of a transformation of a function in general that has an f out here, but our parent function here was the squaring function. So this is the general form of the squaring function. We're going to call this again vertex form of our parabola. Some important things to note when we have it written in vertex form is that the vertex of the parabola is going to be at HK. We're also going to know the axis of symmetry, which is going to be an equation x equals h. So we'll get some questions about those things as well. There's nothing to do with the first question because it's already written in the form where h is 0 and k is -2. So we're just going to shift our parent graph of our parabola down 2 and go right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4. We get the parabola has been shifted down 2. That's just a sketch. If you want to get it better, let me try and get that a little better here for you. Zoom in on a little bit better. So down 2, down 2, down 2, oops. Then this one was 2, 4, so down 2 and down 2. We get something that looks like so. There we go. This one is also already written in vertex form. We don't have anything to do to that, but we do have a reflection and a stretch here. So we're going to start with the vertex stays at 0, 0. Now when I go right 1, I need to go down 5. When I go left 1, I need to go down 5. When I go right 2, I need to go down 20, and that's not going to happen. So I'm just going to have to draw this with what I have. It's going down very quickly, like so, but it still looks quadratic. Now we have a positive 1/4 x squared. Again, there was no horizontal or vertical shift. It stays right there at 0, 0. But now at let's pick a value that was out here, like 4/16. When I take 1/4 of that, I'm going to get 4. -4/16. When I take 1/4 of that, I'm going to get 4. So this is going to grow very slowly. It's going to be a lot wider, like so. Now we're going to get into some where we have to complete the square. So remember our perfect square trinomials from algebra looked like so. A squared plus 2ab plus b squared was equal to a plus b squared, and a squared minus 2ab plus b squared is equal to a minus b squared. That's one of your special factoring techniques for what's called a perfect square trinomial. We're going to try and force a perfect square trinomial to show up to help us get it into the form of a times x minus h squared plus k. This part right here, we're going to try and force this perfect square to show up. And that's what we mean when we say we're going to complete the square. So the first thing that I want to do is I want to factor the -1 out of the x parts, leaving me with an x squared plus 2x on the inside. I'm going to leave me with some space there. Now I need to come off to the side here, and I either need to think about this or I need to actually do the math to say, okay, 2ab is equal to a -2x. But I know that my a was equal to x already. So I'm going to get rid of that on both sides. That 2b is going to be -2. And when I divide by 2, that means that my b was a -1. But I don't want b, I want to add b squared in here. So b squared is a +1. So I just added -1 times +1. I added a value of -1 to the problem. So the opposite of that I need to add on the outside to balance it out is a +1. That's going to leave me with a -x plus 1 squared. The square root of x squared is x. The square root of 1 is 1. And I keep the sign of the middle. That's what this factoring technique tells me to do with a perfect square trinomial, and I've got a +1. That tells me that my vertex is going to be at -1, 1. And I've got a reflection here so that I'm going to multiply all my traditional y values by a -1. So I'm going to go right 1, down 1. And I'm going to go left 1, down 1. So there should be an x-intercept at -2, 0, and there should be an x-intercept at 0, 0. And then I'm going to go right 2, down 4. 1, 2, 3, 4. So there should be a point at 1, -3, and left 2. So I'm at -3, down 4. And there should be a point at -3, -3. And again, it's not that great of a picture, but you can get a better picture if you want to stick it into your graphing calculator to confirm that, or if you want to use Desmos as a graphing calculator. My focus today is to show you how to complete the square. We already talked about the transformations in a different video, and I showed you those graphing techniques. So the focus of this video right here is on getting it into vertex form and completing the square. I don't have a multiplier in front of x this time like last time, but I am going to separate out the x's from the constant so that I can take half of the middle term and square it. Half of 2 is 1. 1 squared is 1. I can't just throw a +1 into the problem without balancing it out with a -1. So this is going to be x plus 1 squared minus 4. That puts my vertex at -1, -4. And it's going to keep the same shape as the original, right 1, up 1, left 1, up 1, right 2, up 4, and left 2, up 4, and it's going to look like so. There we go. In this problem, we have a multiplier in front of x squared that we're going to factor out before we get started. If you want to check yourself that you did the division correctly here, 2 times -2 is a -4. Okay, so that will get us back to our original. We want to take half of this middle number and square it. So half of 2 is going to be 1. 1 squared is 1. We just added a -2 into the problem, so we balance it out with a +2. That makes this -2 times x plus 1 squared minus 2. That puts our vertex at a -1, -2. And that means when we go right 1, we're going to go down 2. When we go left 1, we're going to go down 2 because of that multiplier of -2. And our parabola is going to look something like that. Okay, this one looks a little crazy, right? And it is a little crazy. We're going to factor out that 5/7. We've got x squared plus 2x. When we do that, we're going to leave that -1 on the outside. We're going to take half of the middle number and square it. So there's a +1 in there. And I just added a 5/7 into the problem, so I need to subtract a 5/7 from the problem. This gives me 5/7 times x plus 1 squared. This is a -7/7 minus 5/7 is going to give me a -12/7. So my vertex is at -1. -12/7 is -1 5/7. So that's down here somewhere. And then I would go to the right 1 and up 5/7 would get me straight to -1, I believe. Yes. And left 1 and up 5/7 gets me there to -1 as well. And so this one is going to be pretty wide and short, like so. Again, you can get a better picture of that on Desmos. The focus right now is to get it in vertex form. Let's complete the square on this last one right here. And then we'll make another video on the next section of problems where we're going to find the axis of symmetry and the vertex by completing the square. So we're going to factor out this -1. Leave that -10 sitting out there. Half of the middle number squared is going to be a -4 squared, is going to give me a +16. I added a -16 into the problem, so I need to balance it out with a +16. And that gives me an x -4 squared plus 6. My new vertex is at 4, 6. And I have a multiplier of -1 in front of the function. So I'm going to go right 1, down 1, left 1, down 1, right 2, down 4, and left 2, down 4. Yeah, right there. And this is going to look like so. All right, We'll come back next time and we'll do some more completing the square to get it in vertex form, and we'll find the vertex and the axis of symmetry with those problems.